Hey, Charger fam, it's Mrs. Boyd here. We're going to be talking today. Oh, you can't even see it. Dag. You move it. Graphing quadratic functions. There's a lot of pages, but really it's the same process 4 different times, so don't despair. Here we go. Quadratic function, don't forget, is ax squared plus bx plus c. It's right here. And this is standard form. A is always the number in front of x squared, B is always the number in front of x, and C is always the constant. So our first function that we're going to graph is f of x equals x squared. To find our axis of symmetry, the line that splits the vertical line that splits the parabola in half, is our formula is x equals negative b over 2a. So I'm going to write this function in standard form a little bit more so we can see what a, b, and c are. We've got f of x equals 1 x squared plus 0x plus 0. And I'm going to write here that a is 1, b is 0, and c is 0. So we can just refer to that. So our axis of symmetry, x equals negative b, well, that's a negative 0 over 2 times 1. Well, 0 divided by anything, in this case 2, is 0. So x equals 0. And that's our axis of symmetry. To find our vertex, we're just going to find all the things first, and then we'll graph it. To find the vertex, we're going to take the axis of symmetry and plug it into our equation. So that'll be f of 0. X is 0. And that's 0 squared. Well, that means f of 0 is 0. So our vertex is 0, 0 at the origin. I don't care about the vertex form or the factored form. We'll talk about one of those later, but not yet. Let's graph what we have so far. I'm just going to make our axis there in the center. And our point for our vertex is 0, 0, right here in the middle. We're going to use the 1, 3, 5 rules. So 1 and 3 and 5. If I want to graph my parabola quickly, I'm going to start at the origin here and use the 1, 3, 5 rule. That means I'll go right 1, up 1 for the 1 part, right 1, up 3, 1, 2, 3 for the 3 part. And if I had room, I'd go right 1, up 5 for the 5 part. Now, parabolas are symmetrical, so I can do the same thing to the left. Left 1, up 1, left 1, up 3, left 1, up 5. So those are my points. The axis of symmetry is here in the center. Now I'm going to write those points down. I'm going to put my vertex in the center, 0, 0. To the left, I went negative 1, positive 1, and negative 2, positive 4. To the right, right 1, up 1, right 2, up 4. So the y portions, the f of x part, should always be symmetrical about the vertex. So if this is the vertex, that means these two should be the same, and these two should be the same. Roots and zeros. What x coordinates do our parabola cross the x-axis? Well, there's only one, and it's at 0. It's right here. That's where it touches or crosses the x-axis. Domain and range. Domain for parabolas is always all real numbers. Range. We're going to look at the y-coordinate of the vertex, so that's 0. It's going to have y and 0. So the parabola is found above the vertex. That means the range is going to be greater than or equal to that vertex point. There's a lot to digest there. We're going to do a few more together. Don't despair. You see, I'm going to figure out where the next one is on my screen here. Oh, it's right here. All right, this time we've got f of x equals negative x squared plus 4. Let's write this in standard form again. We have f of x equals negative 1 x squared plus 0x plus 4. That's a 4. That means a is negative 1, b is 0, c is 4. Axis of symmetry first. We do x equals negative b, negative 0 over 2 times negative 1. Well, that means x is negative 0 over negative 2. That's still 0. If we want to find the vertex, we plug in that value to our equation. F of 0, that's negative 1 times 0 squared plus 0x plus 4. That means f of 0 is 4. So our vertex is going to be 0, 4. We don't care about these two. One thing I did forget to say, I didn't forget, but we haven't said it yet, the y-intercept can always be found at C. So that's an easy point to find. All right, to plot the rest of these points, the 1, 3, 5 rule. When our A is not 1, we're going to take that A value and multiply it by 1, 3, and 5. So that means we'll have negative 1, negative 3, and negative 5 instead. So let me get, there's a way to draw a straight line on here. Dang it, where's it at? All right, I drew a coordinate grid. It's very exciting. So for this point, we're going to start our vertex is at 0, 4. So we start at 0 left, right, 4 up. That's our vertex. A 1, 3, 5 rule is negative 1. So right 1, down 1. Negative 3, right 1, down 3. Negative 5, right 1, down 5. Same thing on the opposite side because these are symmetrical. We connect the dots and have a parabola. Let's write our points down. Our vertex is in the center here. And then we have to the right 1, 3, and then 0, 2. Oh, just kidding. I did those backwards. 2, 0. And then above or to the left, it'll be the negative 1, positive 3. And then negative 2, 0. Our root, our 0, where these cross the x-axis is right here. So that'll be when y is 0, these two places. So that'll be 2 and negative 2. Domain, always all real numbers. Range, we do y, the y value of the vertex. Our vertex opens down, so it'll be less than or equal to. Another one thing I forgot to mention, above, is that if A is negative, your parabola opens down. If A is positive, it opens up. So we knew ahead of time that our parabola was going to open down because our A value was negative. Okay, let's move on to the next part here. Got a new function, f of x, which is the same as y, by the way, equals x squared plus 6x plus 8. Well, we already know a is 1, b is 6, c is 8. Axis of symmetry first. X equals -6 over 2 times 1. That means x equals -6 over 3 or -2. Oh, I did that so wrong. -2 times 1 remain, or +2 times 1 is still 2. So x is -3. Sorry about that. We plug that into our equation and get for f of -3. And that's -3 squared plus 6 times -3 plus 8. F of -3 is +9 minus 18 plus 8. That means f of -3 is -1. So our vertex is -3, -1. It's going to open up, and our y-intercept will be 8. So those are good things to know when we're going to start graphing. Let's scoot it on down. Let me make our lines real quick. All right, put our coordinate grid on here. We'll use the 1, 3, 5 rule. Oh, let's put our vertex on here first. -3, -1. That's our vertex. So our A is 1. So it'll just be 1, 3, 5 that we use from here. Right 1, up 1, right 1, up 3. Can't do 5. So we'll do the same to the left. And we have ourselves a nice parabola. Our axis of symmetry is right here. Our roots, we've talked about that, are here. So let's start filling out our tables that we need. The vertex goes in the middle, and that we said was -3, -1. To the right, we have -2, 0, and -1, 3. To the left, we have -4, 0, and -5, 3. Roots and zeros, we already know that those are at -4 and -2. Domain, as always, all real numbers. Range, y, it's facing up, so it's greater than or equal to -1. All right, I think you're probably getting it. Let's keep going one more, and then we'll call it a day. This time we have an a value of 2. So let's write what we know down. A is 2, B is -4, C is +6. It opens up, and our y-intercept is 6. Axis of symmetry. X equals -4 over 2 times 2. I'm going to have you always put the negative there and then write whatever B is. It's easy to make a mistake here, miss a sign, and it really changes your parabola a lot. So this is x equals 4 over 4. That means x is 1, our axis of symmetry. For the vertex, we plug 1 in here. We have 2 times 1 squared minus 4 times 1 plus 6. Well, that is merely 2 minus 4 plus 6. That means f of 1 is 4. So our vertex is 1, 4. We don't care about those two. Let's graph what we know. Let me just make the lines for us real quick. I don't know why I didn't do this before now. All right, so vertex is at 1, 4. You know what? Let's do some changes here. I'm going to put our axis of symmetry, or our coordinate grid, way down here. There we go. So we'll start at 1, 4. 1, 3, 5 rule. Our A value is 2, so that becomes 2, 6, 10 rule. Up right 1, up 2, and then we can't go any further. There's no more up here. Our axis of symmetry will go right here. Our y-intercept was at 6, like we said, and it's right there. It opens up, which we said, which is true here as well. So let's write our points down. Our vertex, we know, is at 1, 4. Our next point to the right is at 2, 6. We go right one more, that'll be 3, and 6 plus 10. Oh, I graphed it wrong. Oh, Lord. I'm so sorry. Let's fix this real quick. It should be right 1 up 3. Left 1 up 3. Oh, nope, it was 2. I was right the first time. Let's see if I can put that back. Hooray, I did it. All right, gosh. Oh, so the next one will be right 3. So 2 plus 3. 2 plus 1 is 3, and then up 6 from that. Oh my gosh, I've lost it. Is 12. I've done this backwards. This one has really just gotten away from me. 1 to the right is 0, and then -1, and then 6 and 12. Whew. I did that completely backwards, and I totally apologize. Roots, there are none. There's nowhere where our graph crosses the x-axis here. The domain is still all real numbers. The range, even though I got it real wrong, has y in 4. It opens up, so it's greater than or equal to. Sorry about that last one. I really got crazy there. I hope this makes some sense to you. It's a bit of a process. There's lots of steps, but I know you can do it. Let me know if you have any questions, and I'll talk to you real soon.